Hi, I'm Evan. Marco, what's wrong?
My tire broke.
Well, you can't use this tool, silly. You need a wrench.
Boy, isn't he handy?
Right?
Now apply the wrench to the bolt.
Okay.
Now, if you emit a force in the counterclockwise direction, you'd be emitting a positive torque.
And if you put the force in a clockwise direction, you will have a negative torque.
Okay. So why would it turn?
You see, if you were close to the pivot point, you'd be emitting a small torque with the same amount of force.
So does this mean that further away from the pivot point, I will emit a more torque with less effort?
Correct.
Wow. So, what happens if I push the force this way?
Let's see. Nothing, right? Well, because we see you're pushing at a 0-degree angle. Now, if you're to push at an angle, it's going to make it easier. So the closer you get to a 90-degree angle, is the easier it's going to be to push.
And that's because 90 degrees is the ideal angle to have the maximum torque, right?
Correct.
Wow. It's fixed. Thank you, Chris and Evan. That's cool. Welcome back.
What seems to be your concern, Evan?
I don't understand why this ball keeps going in a circle.
Well, that's because of centripetal force.
Centripetal force? What's that?
The extension of this string is what causes the ball to move in a circular path. Normally, the tangential force being applied would cause the ball to move in a linear motion. However, the tension of this string is acting as a centripetal force, causing the ball to rotate.
Wait, linear? Don't you mean the centrifugal force?
The centrifugal force is not an actual force, it's just what the ball, in this case, is experiencing.
Okay.
Yeah, so the ball is just constantly accelerating throughout its movement.
Next. Wow! Centripetal force is so cool!
Oh no!
Hi! Welcome back! Again!
What are you doing with that ball in your hand?
Well, I keep throwing it up in the air and it just keeps falling down. I still don't understand why this ball drops the way it does.
Well, consider the following. If we were to drop both of these balls at the same time, would they hit the ground at the same exact moment?
Well, no, because this basketball has a larger mass than this little basketball.
I don't know!
Let's find out.
Wow.
What the heck?
Well, that's because of free fall acceleration. Both objects are falling down at a negative 9.8 acceleration.
Oh, so well, does that count for everything?
Yes. Even this onion.
So ready? 1, 2, 3. What in the world?
Even me! Science! Now do you get it?
Yeah, everything falls into place.
So now we'll demonstrate a free body diagram for torque. This point here will be our pivot point. This line here will be our wrench. Now, you will want to exert a force of a 90-degree angle. So this will be our force. And you will exert it at a counterclockwise. Now, this will equal to a great torque. Now, this 90-degree angle will not give you the same amount of torque as this 90-degree angle. This is because this angle is closer to the pivot point to this angle, meaning the further away from the pivot point you are, the greater torque that you will get. So for a 45-degree angle, which will go like this, you will have way less torque than a 90-degree angle. And that's how you do a free body diagram.
And for our example of centripetal force when we're swinging the ball around, I will draw a free body diagram to show it. So, in our example, we have our ball, and it's swinging around this center right here, in this little motion right here. This is a circle. Okay? So, the centripetal force is going inwards. And that, in this case, is this tension of the string. The tension of the string. Now, the ball is also trying to move in a tangential motion, as all objects do. So this is its tangential direction that it is trying to move in, which in this case is, the centrifugal force. And as it travels around here, it always is attempting to move in that line. Now, depending on where you are on this string, the tangential acceleration and velocity will change. But no matter where you are on the string, however, your angular acceleration and your angular velocity will remain constant. And keep in mind also that while this ball is traveling, it is still in effect with the Earth's gravity. So the weight is always being directed downwards, no matter where it is on this arc.
We'll be explaining the free body diagram for gravity. So there's only really one main force acting upon this object that is falling in free fall, which is the gravitational force. The gravitational force is affected by the object's weight, which is force W. When the object is falling at an acceleration of negative 9.8 meters per second squared. And that's the end.
Fuck this stupid ball. Fuck this stupid ball.